Yeah, so I'm starting the recording here, so I'm just going to answer that again. Yeah, the exam number 3 is going to work exactly the same as exam number 2 and exam number 1, in the sense that there will be 2 portions. There's going to be an online ALEX portion, as before, and there's going to be an in-class portion. And the in-class portion, if I should be there to proctor it. It's almost guaranteed that I will be there because the quarantine period is 10 days and the 10 days are up on Tuesday, which means that even if I'm not 100%, well, yeah, basically they're letting me go back on campus after Tuesday, which works out. I'll be there on Wednesday. But if for some reason I'm not able to make it on Wednesday, I already have somebody as a backup to be there for me on Wednesday. So yeah, does that answer your question?
Yeah.
All right. Excuse me. Yeah, I got a little bit of a cough, and a little stuffiness, but other than that, I feel fine. um, yeah, so it's not a. Yeah, it's mainly that they asked me to, there's just a standard number of days you're supposed to stay home or something. So that's where I'm at. All right, it is 8:30, so we can go ahead and get started. And sorry for this is just unfortunate that this had to come up at the end of the semester. And just that we're ending differently than how we started, but but this is what I got to do, I guess, and this is what I'm supposed to do. So yeah, we can hold the session just like before, and you'll be able to see my screen. I'll write things on the board, on my little whiteboard here on my iPad. And then if you have questions, you can ask the questions. I am recording this also, so if you want to go back and watch it again, feel free to do that. So let's just go over a couple of things here before we get started. Let's see here. Okay, so what are some things that we want to go over? Just like the rest of the schedule for the rest of the semester, what do we have left? Can somebody tell us what else is there to do? Today is December 5th, right? So we're supposed to be reviewing module 3. As usual, we can review ALEX stuff, or we can review worksheets 5 and 6. Because all that's left besides today is exam number 3. And you should know what to expect on that exam in the sense of the format of it and everything. But that's what's going to happen on Wednesday in class for the in-class portion, and then you have time to do the ALEX portion outside of class. Okay, so are there any questions about exam number 3? Yeah, this is the only day today. We held this online just because it was a little bit difficult to get people to cover. And then today's a review day. We can do problems. I can easily review here online. It's not really necessary to be in person in a sense. Okay, so if there aren't any questions, then we'll be there on Wednesday for that in class, at the usual time. And then other than that, we have worksheets 5 and 6 that the in-class portion of the exam is going to cover. So 2 problems from worksheet 6 will probably be selected, and they'll be very similar to what's on here already. And then 2 problems from worksheet 5, that's usually kind of where I go. Okay, so yeah, so that's what we'll have for the worksheet. Oh, I'm sorry, the exam number 3. And then I also wanted to comment on a couple of things here. David Hambley put out an announcement. And so let's just kind of go through it really quickly here, because we're almost at the end, right? So we want to just do whatever we can to try to do as best we can on this exam. So our exam is coming up on Wednesday. And so some of the resources available, we have office hours. These have been up all semester. So, you can go to the Getting Help page on Canvas and then just scroll down and see, lots of people have office hours. Later today, David Hambley has office hours, kind of just going through here. You can see all the people who have Monday office hours, and you know, you're welcome to go visit them. The Math Center is also open. There's a practice exam. This has been you know, true for every exam. So if you haven't done the practice exam, that would be a good idea. You know, it'll give you an idea how prepared you are. And then there's also a reference sheet, which you can, if we get stuck on a problem and it requires some sort of trig identity or the unit circle, we can reference this. Okay, I'll pull this up in just a moment. And then finally, oh, and then there was this nice one here I saw. It says, you have any materials provided by your instructor, which I've posted videos on YouTube with links in the announcements. But David Hambley has also been posting some videos throughout the semester. So you're welcome to click, you know, on his link that he put in this, you know, he put there. And then he gave a nice little list. Oh, let me minimize this. A nice little list of you know, worksheet 5 and worksheet 6 videos. He also did some other ones, but you might not want to focus on worksheet 4 now since we've passed that. But if you want to see David Hambley introduce the information, feel free to you know, click on that, and you know, you'll get a different perspective on that. So that could be nice. Okay, and then obviously study groups if you study with anybody in class. All right, cool. Any questions? From anybody today? And you feel free to use your microphone if you like, or you can just put it in the chat. Oh, I see something in the chat. Oh yeah. Oh, cool. And then I can see somebody sent me like a private direct message here. You feel free to do that as well. It says, can you please go over problem 5B of worksheet 6? So yeah, we can do that. Let's do that. All right. And I'm assuming you can see my screen here. Let me know if you can see my screen.
Yeah, we could see it.
Okay, cool. All right. So this person asked for 5B on worksheet number 6. So we can go over this problem here. Oh, where's my pencil? All right, so let's get this set up there. So you know, if you watch the video on these problems here, you know that we need to know the basic shape of the tangent function. So maybe we'll review that here really quick, and then we'll find the graph of this one. So what values are important on the tangent function? F of x equals, let's just say, tangent of x. One period of the tangent function, it actually goes, it's centered at 0. And then it goes back by units of pi over 4. So negative pi over 4. And then negative 2 pi over 4, which reduces to pi over 2. And then in the other direction, since it's centered at 0, the other side would have pi over 4 and pi over 2. And so this function has vertical asymptotes at negative pi over 2 and positive pi over 2. And I think I drew a table in the video that I made. So let me go ahead and just draw it one more time. And this is what we have to know in order to be able to draw, you know, this other transformed function. So we have our values are negative pi over 2. There's 5 x values in a sense that you could do, x values and then y values. There's 5 x values for each of these trig functions. There's 5 important ones. So negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. Okay, and then what are the y values, the output values? Well, we just said at negative pi over 2 and positive pi over 2, this function is undefined. So there's a vertical asymptote there. At negative pi over 4, the tangent of negative pi over 4 can be calculated to be negative 1. And this is one of those things that we would go to the unit circle for. So maybe I won't go through it in great detail. But if you go to negative pi over 4, which is down here at 7 pi over 4, that's pi over 4 in the negative or in the clockwise direction, Tangent is y over x. Y divided by x. If you divide these two values, you get -1, right? So we got -1. The tangent of 0, again, y divided by x. 0 divided by 1 is 0. And then the tangent of pi over 4 is 1. Okay, and so this is the basic tangent graph that we need to know. And if we know this one well, we can graph all the other ones, oops, fairly easily. All right, that's a sketch. Okay, so what are two things that we're asked to find? VS, so that would be the vertical stretch. Can somebody tell us what the vertical stretch is for this one? You can type it into the chat. Yes, I got a couple messages. Good. Yeah, the vertical stretch would be, it's being stretched by a factor of 2. Very good. Yeah. And so you can imagine, instead of, let me draw this in let's do purple. Instead of at 1, it's going to be stretched by a factor of 2. So it's going, the function is going to be stretched vertically, but there's other things happening. Some people put -2. The negative is going to flip the function about the x-axis. So instead of being just stretched vertically like this, it's actually going to get reflected about the x-axis. I'll put big circle here and a big circle right here, like the just exaggerated points there. So it's going to look something like this. Okay, so that's what my vertical stretch does. The -2 stretches it vertically, and the negative flips it. And so then the last thing is, then there's a pi over 4 in there, which changes the period, the amount of time it takes for one cycle to complete. And so does anybody remember the formula for the period of tangent? What is the formula for the period of, and let's do f of x equals a tangent bx. Very good. Yeah, I see somebody typed it in, sent it to me. Anybody else? The period is, oh, good. Yes, it's actually pi over b. Very good. Pi over b. Somebody sent me 2 pi over b. 2 pi over b is for sine and cosine. Yeah, so very good. It's pi over b. So the period of the one that we're working with right now is going to be 2 pi over b, which is pi over 4 in this case. Okay. And then so we figure out, okay, what is this here? What is this equal to? This is 2 pi over 1 divided by or multiplied by the reciprocal of pi over 4. If the pi's cancel, then we can get 8 here. Our period is going to be 8 units. And we, in our class, talked about a horizontal increment that we would use. A horizontal increment, which is basically just the period divided by 4. And this is going to be like the increment that we use to label the x-axis. And so that's 8 divided by 4, which is 2. And so we're going to use this value 2 from 0. I'll move over 2 units and I'll mark 2 here. And then 2 more units and mark 4 here. And in the negative direction, -2 and -4. Excuse me. And now we're ready to sketch our function. So our vertical asymptote would go at the ends of this one period. Notice that one period goes from -4 to +4. So it has a period length of 8 units, which is what it should have. That's what we calculated. Let's see here. And then somebody said, is it pi? You're right. Thank you. Yes, a little mistake there. So I said the period is pi over b, right? But then I wrote 2 pi over b for some reason. Sorry, I guess I'm still a little off here. So let me delete that too. Yeah, thank you for that. Somebody was, eagle eye viewer there. I'll cross out that 2. I'll cross out this 2. And so this should be 4 then, right? And so our horizontal increment then would be, we're basically just going to divide everything by 2. So it will be 4 divided by 4, which is 1. All right. And so my, on the horizontal axis, I'll still use 2 units, just to make it nice and, nice and spaced out here. But the horizontal units, I'm going to mark them in purple now, are -2, -1, 1, and 2. Okay. Excuse me. Okay, so we're the increment that we use from the origin is 1 unit, 1, 2, and then -1, -2. Okay. And then we said it's been reflected about the x-axis. So our y value, I'll mark 2. And then -2 is right there. And so we have 1 point here, a point at the origin, and then 1 point down below. So our graph looks something like this. And they're a little bit tough to draw sometimes. But, as long as you get the rough idea there, it's okay. Okay, so is that okay for whoever asked?
Do we have to put the point?
Do you have to like label the points?
Yeah.
I would say no, as long as you scaled the axes. Like I think it's pretty clear what the points, what the coordinates of the points are. So I think in the instructions it does say label points and or scales appropriately. And so what I did is I scaled it fairly accurately. If you did not write any scales, along the X and Y axis, then you should label the points. Yeah, so you should make it clear what those points are. But by the way I scaled the axes, I think, you can tell what the coordinates of those points are. All right, good. What other questions do we have? We can also take a look at some of the inverse trig function problems. Question 5 on ALEKS. Okay, good. Let's take a look at that one. So we have the ALEKS practice problems form as well. And so let's take a look at question 5. Okay, this one's nice. Okay, and then I got another question from the previous problem, so let me answer that real quick. It says, how did you know the proper scaling values? Is it from the period? And the answer is yes. I use the terminology, okay, so we should all know how to find the period. That's just a standard. This is, if you ask somebody for the period of a tangent function, everybody, no matter what textbook you're looking at, they will say pi divided by b, right? We highlighted that earlier in green there. So we found the period. Now, how do we scale the axes? The horizontal axis, I use, a horizontal increment. And the way that I find that is by taking the period that we calculated, this period of 4, and dividing that period by 4. So no matter what the period was, even if it was, let's say the period was 2 pi, then you would divide that by 4. And that would be the increment that you would use to label the x-axis, okay, or the horizontal axis. Since we got 1, and we know we from the beginning we said, okay, well, this is what the basic function looks like, the tangent function. It goes 2 steps to the right and there's a vertical asymptote. From the origin, you go 2 steps to the left and there's a vertical asymptote. We use this horizontal increment of 1 unit, and we said, okay, 1 unit to the right, 1 unit to the 2 units to the right. That's our labeling in that direction. And then 1 unit to the left, 1 unit to the left. You know, so that's it in that's the x taken care of. The y, we know that the tangent function has special points at 1 and -1, but since it was scaled by a factor of 2, the y axis was labeled, 2 units up and 2 units down. Okay, good. All right, so somebody asked for question number 5. This is a nice one. Suppose that x comma the square root of 5/5 is a point in quadrant 2 lying on the unit circle. Okay, so you can try to look for this. There are tons of points on the unit circle that are not actually there are. Notice that there's a point right here where my cursor is on the unit circle, but it's not special enough to be labeled, right? So there are way more points on this unit circle than the ones that are labeled here. The ones that are labeled are of special angles, but there's many on here, let's say in quadrant 2, that are not actually like listed. They're just points on the circle. And so that's this is an example of one. Square root of 5/5, you'll never find that on this unit circle here. It is on here somewhere, but it's not labeled because you can't label them all. There's just too many. So, we can draw a portion of the unit circle here in quadrant 2. And there is a point on here. Let's just pick it right here. It doesn't really matter where we put it. Its coordinates, the x coordinate is unknown. The y coordinate is known to be square root of 5/5. And what's the value of, so we don't know x, we know y. Does anybody know what r is equal to?
One.
It is 1. Yes, because we are on the unit circle. Yeah, when we're talking about the unit circle, the r value is 1. And so we have this, now we can solve x squared plus y squared equals r squared, because only one of those is unknown and we can solve for it. And why do we use the Pythagorean theorem? We use it because we can make a right triangle with this point, the origin, and then just drop a perpendicular down to the x-axis. And we would know that the x coordinate is this length here. The y length, the vertical length here is positive square root 5/5. This hypotenuse is 1. So if you wanted to draw the triangle, you could. And now, okay, this is a right triangle. We can use Pythagorean theorem on it. So x squared plus y squared equals r squared. So x squared plus 5/25 equals 1 squared is 1, and I'm going to write that 1 as 25/25. I'm basically just getting a common denominator because we know that we're going to have to combine these two numbers. One of them has a denominator of 25, so let's go ahead and get both of them with a denominator of 25. So if we subtract 5/25, then we get x squared equals 20/25. If we take the square root of both sides, we need a plus or minus sign. And so we get, which of those two values do we want to keep, the positive or the negative one? Yeah, I see people messaging me here. It says negative, and that's correct. We want the negative square root of 20. over the square root of 25 is 5, so we'll just simplify that. Because notice that we are in the negative direction. If we're in quadrant 2, you should, that's why it's good to draw it out. You should see, okay, we're in the negative direction. Our answer should be negative, not positive. So this is an answer that we could leave if I had this on the quiz, you could leave it this way. But since this is the ALEKS portion of the exam, these problems are to review for your ALEKS portion, then that means that you're going to have to simplify any radicals. So the way I'll do that here is, I think in the most, for this problem here, the easiest way, I guess, in a sense, negative, the square root of 20 is the square root of 4 times the square root of 5, right? Because 20 is 4 times 5, and we can split up a square root. And then the square root of 4, we all know, is 2. And so this is our answer. Okay, for whoever asked that question, is that okay there? All right, very good. And keep in mind that for these problems, this is number 5. We can scroll all the way to the bottom. And there is an answer there, negative 2 root 5 over 5. Okay, so just so we can check, it's always a good idea to check. All right. What else? What other questions do we have? Even any general questions, if anybody came in late or something? And if there aren't any, I can just do random problems on here. Somebody just said, can you please go over problem 10B of worksheet 6? Yeah, we can do that. Oops. 10B of worksheet 6. Yeah, these are all nice. Let's take a look at this. Excuse me. Hopefully you can't hear my kids going wild in the back. All right, 10B. So we have 2/3 cosine squared x plus 5/6 equals 4 over 3. All right, this is the one. Yeah. So how do we do this problem? Can somebody tell me what would be the first step? I might do it differently than what you might like. I'm just curious.
So that we divide, subtract the 5/6 to the other side first.
Sure, we can do that. Subtract the 5/6. Yeah, personally, I would multiply by the least common denominator to try to get rid of all the fractions in the first step. But you don't have to. I'm fine doing it this way as well. It's just then you have to get like a common denominator here, right? Because we're subtracting the 5/6. So we're going to do 4/3 minus 5/6, which is not a problem. I mean, we should be able to do this. So it's, yeah. Just one thing I've noticed over time is, students like getting rid of the fraction. So that's what I usually do, but we can subtract this. If we do, then we get 8 minus 5. That's 3 over 6, which can be reduced to 1/2. So we have, 1/2. Not a big deal. It's fine. And then what?
Then we divide it to 3. 2
Yep.
over 3.
Divide by 2 over 3. And if we divide by 2 over 3, dividing fractions is like, it's equivalent to multiplying by the reciprocal of the one you're dividing by. So that'd be 1/2 times 3/2. And if you multiply that, that's 3/4. So we get cosine squared x equals 3/4. And now we have cosine squared x. We want to isolate, we want to get x by itself, really. So if we isolate the trig function, we want to isolate the trig function first because x is inside of the cosine, right, if you think about the parentheses. So to get rid of that squared, we take the square root of both sides. And so we get the cosine of x is equal to plus or minus the square root of 3 over the square root of 4 is 2. So we'll leave it as the square root of 3 over 2. And so this here, we can actually, you know, in a sense, stop here with our work and give the solutions. Plus or minus the square root of 3 over 2 means that there's a positive answer and there's a negative answer. Now here we don't choose one of them. In the previous problem, we were told we are in quadrant 2. So x must have been negative. When we took a square root and we got a plus or minus, well, x we knew was negative because we were in quadrant 2. In this problem here, we're told to find all solutions in the entire circle. So the value of cosine could be positive or negative. We won't exclude any of these. So here we're not given a specific quadrant. We're actually told to use all the quadrants. So we keep both the positive and the negative solution. And now all we have to do is find angles whose cosine is square root 3 over 2. And remember that on the unit circle, we have an x and a y coordinate. They basically represent the cosine of theta and the sine of theta. Okay, so the first coordinate is the cosine. So we want to know what angle has a cosine, a first coordinate of square root 3 over 2. So can somebody tell me one of the angles when you see, excuse me, square root 3 over 2? What's the first of those angles? And I'll let a couple people respond. Somebody's already responded. Where do we see square root 3 over 2 in the first coordinate?
Is it pi over 6?
Yes, pi over 6. Very good. So right there, yeah, you can see it. Now be careful not to go with pi over 3. Nobody said pi over 3, but just, it does have a square root of 3 over 2 there, but it's in the second coordinate. That would be sine. We're dealing with cosine. So that's this one here. X over r, right? X. So this value here. So pi over 6. X equals pi over 6 is one of our answers. Now, is there another square root of 3 over 2 in the x coordinate? Excuse me. Anywhere else?
In the first coordinate or?
No. In any of the quadrants, is there a square root of 3 over 2? Yes, and I got 2 people responding. 11 pi over 6. That is correct as well. Notice there's a square root of 3 over 2 here in this first quadrant. So the cosine function also has this value when we're at 11 pi over 6. Okay, so 11 pi over 6 is another solution. Now, we could also go to this. Well, what if, we also are looking for x values for angles where the cosine is negative square root 3 over 2. So is there anywhere on this unit circle, any quadrant, where the cosine is negative square root 3 over 2?
Pi over 6.
5 pi over 6 is one of them. Good. Right there. Very good. And where's the other one?
Pi over 6.
7 pi over 6. Very good. Yes, right there. Negative square root of 3 over 2. So there we go. These our 4 solutions. And let me show you something really cool here because, you know, as usual, you know, there's not really lots of time to go over some stuff in class, but basically, and it's going to be a really quick, you know, just showing how to solve that equation graphically. If you remember the graph of cosine, the period is 2 pi, right? So the horizontal increment, as I called it, is 2 pi divided by 4, which is pi over 2. And so we go pi over 2. Another pi over 2 gives us pi. Another pi over 2 gives us 3 pi over 2. And another pi over 2 gives us 2 pi. So our amplitude is 1. And the basic graph looks like this. All right. So we are looking for when cosine of x equals the square root 3 over 2. I don't know exactly what that number is equal to, but it's some positive number. It is less than 1. And then negative square root 3 over 2. You know, so just a quick little visual representation here. On the interval from 0 to 2 pi, how many times is cosine of x equal to positive square root 3 over 2? Well, once right here at some angle between 0 and pi over 2, that's the first quadrant. Well, that's pi over 6. You know, that's what we found on the unit circle. And then again, another time, close to the end of the period, between 3 pi over 2 and 2 pi. That is the fourth quadrant. Well, that's 11 pi over 6. Right? So you should, in a sense, expect 4 solutions, 2 from the negative square root 3 over 2 and 2 from the positive square root 3 over 2. Okay, so yeah, there's more we could say on that, but just I thought that was a kind of a nice little thing. You know, just because you know, some people started by saying, oh, you know, pi over 6 was the first answer, but then, you know, are there more solutions? Well, here's one way that you could tell. There's supposed to be 4, so we keep looking on the unit circle. All right. Any questions there? All right. Excuse me. What other questions do we have? So far, you know, we've been getting questions in the chat. That's good. Can you go over worksheet 6, problem 7b? Yeah. Oh yeah, that was a good one. Let's take a look at that one. Yeah, this is one of the days I wasn't there. You know, when you guys went over this, somebody covered for me on that day. So I did try to post a video, you know, also, you know, just in addition to the discussion day. All right. So, oh, excuse me. All right. 7b, worksheet 6. So, all right, we have the sine inverse of the cosine of 5 pi over 6. Yeah, this is not too bad. So we should work from the inside and work our way out. So let's go and I'm going to zoom in here and just figure out what is the cosine of 5 pi over 6. We go over to the unit circle and we ask ourselves, what is the cosine of 5 pi over 6? Can somebody tell us what the cosine of 5 pi over 6 is? All right, and I see. Anybody else? It is negative square root 3 over 2. Okay, so can everybody see that? We go to 5 pi over 6, and we said cosine is the x coordinate. It's really x divided by r, but r is 1. So this number divided by 1 is just this number. So the cosine of 5 pi over 6 is just this number here, which means we can replace the cosine of 5 pi over 6 by that number. And so now our problem is simplified a little bit. We've simplified one step, and there's only one step left. Now, the last thing to do is figure out what the sine inverse of negative square root 3 over 2 is. Now, this is where it gets, a little bit more complicated in the sense that, this is the newer material. The range of the sine inverse function, sine inverse of x, is negative pi over 2 to pi over 2. Which means that the answer to this question is going to be in one of these two quadrants, quadrant 4, because if you rotate in this direction, negative pi over 2 is right here. If you rotate in the other direction, positive pi over 2 is here, and then 0 is in the middle, of course. So we're looking for an angle in one of these two quadrants whose sine, so let me write this in red here. I think I did this in my video. We want an angle theta in negative pi over 2 to pi over 2, where the sine of theta is equal to negative square root 3 over 2. So can somebody tell us, remember that sine is y divided by r. In which of these two quadrants is the sine negative? Is it quadrant 1 or quadrant 4?
4.
4, right? Because the quadrant 4 is below the x-axis, and therefore the y values are negative. So the angle that we're looking for is some angle down here between 0 and negative pi over 2, and its sine is negative square root 3 over 2. And so we can actually go to the unit circle for help. We go to our unit circle, go in quadrant 4. And which of these angles here in quadrant 4 has a sine of negative square root 3 over 2?
Five pi over 3.
5 pi over 3. Very good. So theta equals, I'm going to put theta equals 5 pi over 3. Hopefully everybody can see that. I'll use my cursor here. At 5 pi over 3, we see that the sine is negative square root 3 over 2. This is an angle in quadrant 4. Now, 5 pi over 3 is not the final answer, because our answer has to be between negative pi over 2 and positive pi over 2. And this angle is not between those two values. 5 pi over 3 is bigger than pi over 2. And so what we can do is we can use coterminal angles to subtract 2 pi to find a smaller angle. Okay, so I'll use a common denominator here. We'll multiply by 3. And what do we end up getting? 5 pi minus 6 pi is negative pi, and the denominator would be 3. So negative pi over 3 is our answer. Now, maybe you could just see that, and that's fine. If you can, that's good. You can just see that, well, here from 0, if I rotate down in this direction to 5 pi over 3, how much of a rotation have I done there? Because this is 2 pi. At 0, you can count that as 2 pi, which is 6 pi over 3. If I'm at 6 pi over 3 and I rotate to 5 pi over 3, I've taken off 1 pi over 3. I've rotated negative pi over 3. So you can also do it that way if you don't want to do this little calculation here. Okay. Questions there? These are a little bit more involved, and somebody asked for this problem, so we did this one. But there are some more like warm-up problems in this worksheet if we want to go over one more of those. This one had 2 layers to it. For the student who asked this question, is that okay? All right. Very good. What else? What else should we look at? We probably have time for one more problem. Any other suggestions? Can you please go over problem 8A of worksheet 6? Yep, sure. Yeah, and I tried in the video that I posted on YouTube in the, before, I tried to do a problem that was similar to each one of these. So, if, feel free to watch that video. I tried to make them similar enough where it's like, okay, you watch this problem and then you should be able to do the one similar to it. So just pointing that out, there's a video as well. Yeah, so again, this is another problem where we're a couple steps in. So hopefully, you have a good grasp on the inverse trig functions. So let's start from the inside out, just like before. What does the arctangent mean? What is the inverse tangent? The arctangent is, so I'll write it off to the side here. Arctan of square root 5 over 2. This is really, some angle theta in the interval from negative pi over 2 to pi over 2, where the tangent of this angle theta is equal to the square root of 5 over 2. So this is the opposite over adjacent. And so we can actually just draw this angle. Negative pi over 2 and pi over 2 are right here. And so which quadrant would this be in? So since we're short on time, I'll just tell you which quadrant. It's going to be in quadrant 1. The angle is going to be in quadrant 1 because tangent is positive, right? The rotation would be this way. If we went this way, tangent would be negative because the opposite side would be negative. So we're not, we can usually eliminate one of the quadrants for the most part. So we draw it in quadrant 1. The tangent or opposite over adjacent, we can label square root of 5 and 2. And then we can use the Pythagorean theorem here to find the value of r, if we want to call it r. X squared plus y squared equals r squared. Here we're told nothing about the unit circle, so r does not have to be 1. So we get 4 plus 5 equals r squared. So 9 is equal to r squared. So r is equal to technically plus or minus 3, but we get r equals positive 3. We've said before that r must be positive. So this value of r is 3. Finally, we want to take the sine of that angle that we just, the one we just drew and we labeled. The sine of is equal to y over r, and that would be square root 5 over 3. That is our answer. All right, so what time is it? Okay, so I'll stop showing my screen there, and I will post this recording up, on the YouTube channel, and if you want to go back and watch one of those, feel free to do that. I'll also post the recordings for the next 2 classes as well. So if you want to see maybe other students ask different problems, you can go and watch those as well. Whatever you like. Okay, so if you have any questions, stick around. I'll stick around for a few minutes as long as anybody has a question. General questions, I can answer those. Okay, so I hope you all have a good day, and I'll see you on Wednesday, in class. Thank you. You too. All right. And if anybody has a question, feel free to ask. If it's, a little more private, I can stop the recording, but I'll just leave it on as long as somebody's still here. All right, and let's see here. Okay, yeah, if you missed a quiz, I will be on campus later in this week. I'll be allowed to go back on campus, so you can come to my office and make it up there. Okay, so yeah, since I was gone, it's been a little bit of a, yeah, we'll make it up. Okay, yeah. So just make sure to come to my office hours on Thursday. Oh well, yeah, on Thursday or Friday. Send me an email and let me know, and we'll figure out a time on Thursday or Friday. All right, no problem. All right, Fernando, Miguel, and Adelie, do you all have a question? It's been a while since I taught online, so I remember now. Maybe some people are just away from their computer.